The anonymous feedback. I've actually debated bringing the whole thing in. I have no problem if people don't like what I do, and I'm certainly interested in constructive feedback. When you add curse words in there and start talking about me personally, it kind of detracts from how serious I take the feedback. That being said, okay, so we obviously got the exams returned yesterday in lab. If you did not pick it up, I have it with me today. I have all remaining, like 10 that weren't picked up yesterday. The average was an 81.2. We're a bit behind in returning the homeworks. I expect to have homeworks 4 and 5 and homework on labs 6 and 7 returned. I'm actually aiming to get them returned today. If not today, they'll certainly be over the next couple days. Lab 6 and homework 4, the grading's all finished. I just have to do some post-processing and then email them all out. I would think by the end of the weekend, all 4 of those assignments should be returned. At that point, we will have 3 remaining assignments out. The last homework, the last lab quiz, and the last lab. And we're going to be certainly working on getting those returned as soon as possible. To a certain extent, grading right after the exam slows down because, TAs put in probably over 100 person hours in terms of grading that exam, and a lot of it very quickly, so you could get it back the next day. So they're all taking breaks or going on strike or something similar for pretty much this weekend. Homework 7 is due next Friday, and my plan was to have it out today because I have gotten understanding of some complaints that I tried to release it on Friday and then it sort of becomes Sunday. That homework is not yet ready. So there are 2 possibilities. I don't know which one is which. I am going to be staying up late on Friday night. See, that's how much I love you, that I'm going to give up my Friday night so I can get the darn homework out. So my goal is to get it out today. That may not occur. If that doesn't occur, then I'm going to make that homework a easier. So I sort of have in mind what I want the homework to be. If I end up not being able to get out today, I'm going to make it a bit easier of a homework and get it out tomorrow or Sunday. So it is coming soon. It's going to be on creating classes. And this is the first of the Oregon Trail project, first of the Oregon Trail homeworks. I'm going to give a full demo of that on Monday. I actually have most of it working, but we don't. There's a couple things that aren't working, like you can't actually buy food, which is a problem if you're traveling across country and you're starving the whole way. Okay. That's not an option in the game. So right, it's like the Donner family that ate each other on the way to the gold rush. So we're going to be talking a bit more about classes today. I'm going to finally explain why we even care about public and private. There's going to be a Star Wars reference in the middle. That should be a lot of fun. We're then going to start on arrays. Maybe not Monday, but certainly sometime next week. I want to start getting through arrays because we have a couple of array homeworks. And I generally need to introduce the material before it's actually gone over in lab, and the lab's a week before the homework is due. So in order to keep that schedule, I'm going to move on into Chapter 8 and start going over arrays. Once we've gone through arrays will probably take us 2 weeks or so. Arrays are the bracket and the string bracket arts. We're going to come back to classes and spend the rest of the semester talking about classes. So we're going to hop ahead to Chapter 8 and then work our way back to finish up talking more about classes and advanced class applications, all that fun stuff. Questions, comments, concerns, complaints? You're allowed to express complaints too. All right. So we're going to talk about the use of the static keyword for fields of a class. Particularly, we created a circle class, and we made the pi field static. And what that means is that that particular field is shared by all of the objects. So if we declare one circle object, so every circle has its own radius field, right, because every circle could be a different size, and the pi field was declared as static. And that means that there's one pi field that's shared by all of the objects. If I create one circle object, I have one pi field. If I create 4 circle objects, I still have one pi field. If I create 1 million, a billion, a gazillion circle objects, I still have one pi field. And this ends up doing number of things. One, it saves memory. Remember that we don't need 1,000 copies of a constant pi sitting around in memory. We really only need one. So that's what the static means. Radius is not static. It is called an instance variable or an instance class. The reason it's called that is an object is considered an instance of a class. We have one circle class, right? That's what we've sort of been working on the slide set. And here we have a whole series of circle objects. An object is called an instance of a class, and therefore any variable in that is an instance variable. I'm not so worried that you remember why it's called that, but keep in mind that radius is an instance variable, sometimes called an instance field. Pi, there's only one of them, no matter how many circle objects we declare, so it is called a class variable or a class field, because there's one of them for all the objects of the circle class. And we had talked about that and gone over that in more than just one slide. I guess it was last Friday, because Monday was the review, Wednesday was our fun test. And that's pretty much where we ended. And we had created a couple methods in our circle class, and I'm going to develop it a bit more. So here I have another method in my circle class called 1 over the radius. And you can probably guess what it does just by reading the name. It divides 1 by the radius. I needed a reason to have the radius in the denominator, and I couldn't really think of something, so I just kind of didn't even bother making up some reason. I just said 1 over radius. For whatever reason, you need the multiplicative reciprocal of the radius. So, poof, that does it. So, let's consider a circle test class. So we're outside the circle class. And in our main method, we say circle C equals new circle. And if we remember, that's going to set the radius equal to 0. We then print out 1 over the radius. And here we're going to run into a problem. The radius is 0. We're printing out 1 over 0. And Java's not going to behave very well. And many languages, programming languages, will just crash. They say, I can't divide by 0. I can't continue. Poof, I'm crashing. Well, Java doesn't really crash, but it does something unexpected. So even though Java won't crash, I'm going to call it a crash because it's much more dramatic for this slide set. So we're going to pretend that this would cause Java to crash. In reality, I think it prints like infinity or something like that. It still does something unexpected and undesired. I'm going to pretend it crashes for this. So the problem, again, is that this first line creates a circle, sets the radius to 0. Because that's what the code that we had discussed on the previous couple slides did. And then we tried dividing by the radius, or dividing by 0, and that just causes it to crash. Okay. So, what we need to do is somehow manage to prevent the radius from being 0. Maybe this is a circle class that cannot represent a point. It can represent a circle, but not a point. A point, of course, is a circle with radius 0. So what I'm going to do now is say double radius equals 1. Poof! It doesn't, you create a circle and the radius is 1, it doesn't crash. Right, note that the variable radius is now initialized to 1.0. So this code now works. I create a circle, it gives radius 1, and I print out 1 over 1, or 1, and everything's happy. But now look that I can figure out yet another way to make it crash. I create a circle, I then manually set the radius equal to 0, and I'm sort of back to where I started. I'm still dividing by 0, I'm still running into the same problem. And here I created a circle, and the circle created itself fine. It said, well, I'm going to set the radius to 1 because that's a valid value for the radius. But then I manually set the radius to 0, and therefore, when I call 1 over radius method, it has a problem, and it crashes yet again. In particular, let's say that you're working with a coworker, and usually, and we're going to see this, I'm going to talk about this more once we've seen the course project. When you have really big programs that are being written, computer games, operating systems, stuff like that, it's split up into classes, and you might have half a dozen classes that you have to write, the next person has half a dozen classes that they have to write, and some poor schmo has 1,000 classes that they have to write. So I'm going to say, for sake of argument, that you are writing, or we're writing the circle class, and somebody else is writing the circle test class. So our circle class, by definition, or by my revised definition, is not supposed to represent a point. It's not supposed to have a radius of 0. And we properly do that. We set the radius to 1, so it's a unit circle, et cetera, et cetera. And of course, this has a couple other methods that wouldn't fit on the slide, the constructors, the mutators, the accessors. So here is the badly written code. The person who is using our circle class tries to do something that is not intended for. Tries to set the radius equal to 0. Remember that our circle class is not intended for effectively a point. It's not intended to have the circle set equal to 0. So our coworker has no idea what they're doing and misuses our code. But the crash occurs there. So even though the badly written code is where the radius is set equal to 0 that our coworker did, the crash is in our code. And our code blows up, and our boss comes and says, well, why does our code blow up? And we say, well, it's someone else's fault, and they're not going to listen to that. So the thing that I want you to get from this slide is that even though the badly written code is here, because this is trying to make the circle into a point, which it was not intended for, the error occurs in our code. Because we set the radius to 0, so that radius is then equal to 0. When we print out 1 over radius, it's going to call this method. This is where it does the division. It's going to do the division and then return that value. It does the division here and has a problem. So what we need to do is make it so that our coworker, who's clueless, has no idea cannot change the radius to 0. And that's the motivation for the next half dozen or so slides, is we want to prevent somebody else from using our code and setting the radius equal to 0. So we don't want people using our circle class and being able to modify the fields on their own. We don't want them to say c.radius equals 0, because they're directly modifying the radius, and we have no control over that. So what we're going to do is say, okay, you can't modify the radius field anymore. You are now forbidden or prevented from doing that. And in particular, we're going to give it private visibility. So what that means is only code within that class can modify it. So if the circle class has radius, private double radius, then only the code in the circle class can modify that field. Code outside the circle class, such as in the circle test class, cannot modify that particular field. That's what private means, and I'm going to spend some time discussing that on the next couple slides. So here we have our class circle, and our class circle now has our radius as private. Notice that radius is now private. Okay. Any questions so far before I properly demotivate you? All right. Burnout. Attitudes are contagious. Mine might kill you. Give me 2 seconds. Consulting. If you're not part of the solution, there's good money to be made in prolonging the problem. Not so much? See, I think this is so funny because there's so many computer consultants. Bitterness. Never be afraid to share your dreams with the world, because there's nothing the world loves more than the taste of really sweet dreams. Pessimism. Every dark cloud has a silver lining. The lightning kills hundreds of people each year who are trying to find it. Question.
So basically, the other program for the guy that radius equals 0.0, when that double, it overrides that.
So the question was, what happens when this is private and the other program says c.radius equals 0.0? Java will not allow his or her code to compile, and which is what I'm going to get to. So going back, if radius was private, then Java would not allow this to compile. They could not directly modify the radius field. And I think that's actually the next slide. Demotivator. Right. So now, this code will not compile. Your coworker tries to do it, and Java spits out an error saying radius has private access in class circle. Meaning, because this is in a circle test class, it can't directly modify the radius.
So will the radius always be 1.0 from now on?
Yes. As of right now, and this is the next problem, Okay. The next problem that I'm going to get to in a second or two is that there's now no way to change. There's a problem with changing the radius. We have an accessor, and the accessor can change it. I'll get to that in 2 seconds. Okay. Other questions on this so far? How many people feel they're following along so far? Okay, I'm seeing a good number of hands. This code will also not compile. Here this is saying circle C equals new circle, print out radius. Even though this is not trying to modify the radius field. Like this is trying to read it, whereas that's trying to write it. Like this is trying to set it, and this is just trying to figure out what it is. And if you make something private, it's private for both reading and writing. That's just a feature of how it works. So this code will also not compile. Even though you're just trying to find out what the radius is, Java's still going to say radius has private visibility in class circle. So then the problem, of course, is how do you modify the circle's radius? Because it's set to 1, you can't modify it directly, you can't even find out what it is. Well, okay, you know it's 1.0 because it can never change. And what we're going to do there is we're going to use the accessor and mutator methods that are already in the circle class. So a mutator method would look like this. Void set radius double r, radius equals r. An accessor method looks like that. So, and I'm going to talk about how these are used in a second. We've seen accessor mutator methods like this. I'm going to talk about it in a second or two. So this is our class so far. Radius is private. Here we have our accessor mutator method. So here we have now a circle test that our coworkers write in our new and improved circle class. In particular, here we invoke a method, c.setRadius 1.0. What that's going to do is that's going to call the setRadius method. And the setRadius method is not private, so it can be called. Methods can be private too. I'll talk about that a bit later. That calls the setRadius method. And it passes it in 1.0. So here the setRadius method is called. R is given value 1.0 because that's the parameter passed in. And this is where the actual modification to the radius field occurs. Notice that that modification, right, because we're saying radius, which is here, equals r, that modification is occurring in the circle class. So even though we are setting the radius there, or I'm sorry, we're calling the setRadius method there, the actual modification to the field still occurs inside the circle class. And that's fine, right, because radius is private in class circle. So this is where we can actually make that modification, anywhere on the right side of the vertical red line. So here we call the setRadius method, but the radius itself is actually modified here, inside the circle class, which is allowed because it's private. New cough drop. But we run into another problem. And this problem is we create a new circle, and then we call setRadius. And setRadius gives it 0.0. Say, well, why have I gone through all this trouble just to get back to the exact same problem that I had before? So here we're creating a new circle. That sets the radius equal to 1. Here we tell it to set the radius to 0. It dutifully goes and sets the radius equal to 0, and then it blows up. So that's the problem. But this is very easily fixed. And this is the whole point of mutators. All we're going to do is modify the setRadius method to ensure that no bad values can be set, that the radius cannot be set to any bad values. And that's the code for my setRadius method. Notice now it's not blindly setting the radius equal to whatever value is passed in. It says if the radius is positive, then I'm going to modify it. Otherwise, I'm just going to set it to a unit circle. So when you call setRadius 0.0, it creates a circle of radius 1. Maybe instead of doing this, it should print out an error message. Maybe it should set it to radius 5. It doesn't matter. But the point is that this mutator will prevent the circle class from ever having a radius that is anything other than positive. It cannot be 0. It cannot be negative. according to this. Well, so far. It turns out there's one other way. I'll get to that in a minute or two. And this is really the point of mutators. Mutators now, so this is of course in our circle class that we are writing. So now almost no matter what our coworker does, they can't set the radius to a improper value. The mutator, I don't want to say guards it, but basically controls how the radius field is modified. In particular, controls it so that it's not set equal to 0 or a negative number. Yes?
Do you need brackets?
Here?
Right.
The question was, do you need brackets? If you have a, wait, hold on. Let's have a different color, like brown. Oh, here we go. Is that good for brown? Complain. Is that actually readable? Okay, well I put brackets around it. If the if clause, the thing that's done on the if and the thing that's done on the else, if it is a single line, then you don't need brackets. I often will leave out brackets in the slides just because I'm limited on how much space I have on the slides. But you certainly could put brackets in there if you wanted.
But you're saying it will work without them?
It would work without them, yes. Because here there's only one thing that it does on the if, or one statement, and one thing it does on the else.
Is it more advisable to include the brackets, or is it less advisable?
I'd say include brackets unless you're sure of how it works without them, just to be on the safe side. Because here brackets are optional, but there are other times that they're not. So yeah, I'd say include brackets. Other questions on this? Yes?
Do you really need that else statement? If you just had the if, then we give the radius one.
So the question was, what if I just get rid of the else statement? And you certainly could. You certainly could leave it that way. That would only change the radius if the value passed in were positive. Otherwise, it would leave the radius to what it was initially. And that would certainly be a valid way to go about doing this. Because again, it makes sure that the radius is always set to a consistent value. Here when we say consistent, we mean anything greater than 0. How that's done is, I guess it'd be up to the particular circle class designer. Either one of these achieve the same effect, though, is that the radius cannot be set to a negative value. When you are designing your mutators, you will need to check, and the homework's going to say this, you will need to go through and check to make sure they are not bad values. And what a bad value is will obviously vary with whatever it's being set. An age probably shouldn't be negative, but could potentially be 0 if the person was just born, et cetera, et cetera.
But in the case where we are setting the radius to 1, even though the user did not want to set the radius to 1, shouldn't we be telling the user that we're setting it to 1?
So the question was, if I can rephrase it slightly, shouldn't we be giving an error message? In the original version of this, shouldn't we give an error message if we are setting it equal to 1? And we certainly could, and it depends partly on how the program's used. If you have a graphical program, like a graphical user interface, anything that's printed out is not going to be seen by the user. So then the question is, every time there's a bug in the program, do you want to have a pop-up window saying, radius was set equal to a negative number in circle class, set radius. So one certainly could write an error message in there. It depends sort of on where this program is used. The point is that something should be done if the radius is bad, 0 negative, whether it's not setting it equal to 1, or printing out an error message.
From now on the homework assignment, from the point on, will you put a bad data so that on our homework from now on, we have to put in this stuff to make sure we don't fall into that trap?
Yeah, the question dealt with from now on, when you start doing the designing classes homeworks, which is homework 7 that hopefully will be out today, you will have to set up your mutator so that it doesn't set it to a bad value. And it could be that there are no bad values. Maybe in some other class, maybe the radius could be negative. I don't know, it's an inverted circle. Or maybe it could be 0. So it's certainly possible that there are no bad values for that particular field. But in general, you will need to check if there are any bad values and prevent them from modifying that particular field. And that's going to be explained clearly in the homework. Probably highlighted in red, too. So now there's almost no way to set the radius equal to 0. Turns out there's one small way we're going to get to in a minute, and I'll show you how to solve that. So this is really why we care about mutators. We are writing the circle class. So therefore, we're writing the set radius method. And now we can control how the radius is set. Because the only way to change the radius is to call our method. And here we have put code in, right, this if-else statement, that controls how the radius method is set. Our coworker who doesn't know what he, she is doing can go and try to set the radius all he, she wants. It's not going to do anything because it won't compile. So here we control how that particular radius is set. And this is what mutators do. And this is why we care. This is why the fields are often private, so they can't be set to a bad value directly. And we have the mutators. The mutators allow us, the writers of the class, to control how those fields are set. Right. We're going to see another motivation for it in a minute or two. So it turns out that there are 4 visibilities in Java. We've seen private and we've seen public. So private means only code within that class can read that variable or write that variable. Methods can also be private. A private method can only be called by other code inside that class. Right? So anything that's private in a class, only other stuff in that class can use it. Right, access. Public. Anything that's public can mean any code anywhere can call that method, can use that class, public class, lab quiz 2, can read the variable or write the variable. So public means any code anywhere can do whatever it wants, more or less. There's something called protected. Protected deals with a concept called inheritance. We're going to see inheritance on the last day of class. I'm going to talk a bit about what inheritance is. For those of you progressing on to cs101, they're going to start actually talking about arrays and then move right into inheritance. So protected is another visibility that we essentially won't see much except for the last day. And there's something called default. Not surprisingly, if you don't specify a visibility, it defaults to default. And default is almost the same thing as public. There's a slight difference dealing with something called packages. Again, we're not going to talk about packages much until the last day of class. You can specify visibilities for all the others. I can say protected int radius or protected double radius equals 1.0 if I wanted. I can't say default double radius equals 1.0. Default is sometimes called package as well, but you can't specify it like you can the others. Really, I want you to know public and private. Know that those are the 2 main visibilities and understand the difference. Protected and default, we're going to see on the last day of class and see why we actually care about it. Right, I'll call package. So, visibilities are only for things inside a class declaration. Instance variables, class variables, methods. Turns out you can also have classes within classes. We're not going to be seeing that this semester. So any method, anything inside a class, instance variable, class variable, or method, can have, and actually always does have a visibility. If you don't specify its default, which is kind of the same thing as public. Right, you can specify methods for methods and classes. But you can't specify visibilities for variables inside a method, because it's visible inside that method and not visible outside the method. Oh no.
No, that's stuff.
Any better? All right, let's do this by hand. If you're a 1 or a 2, raise your hand. Okay. Okay, I'm seeing a good number of hands. We're going to spend some time talking about this. We're going to end up coming back to this a bit later as well. So, right. Okay. How many people have heard of DCSS? Anybody? Yes, no? Okay. All DVDs, when they released DVDs, they wanted to prevent them from being copied. And they wanted to prevent, like, you know, some of the copy factories there's a lot of them actually in China, from copying American DVDs and selling them for discount price, because they want to charge us, you know, $5,000 for really crappy movies. Not that all movies are really crappy, but some of them certainly are, and they still charge us like $30 for the DVD. So what they did is they created an encryption scheme. In the same way, I mean, we talked about the Caesar cipher in one of the homeworks. But they created this encryption scheme called CSS, which is Content Scrambling System, which is basically a way for a DVD to have the video that's on there encrypted. And then what happens is your DVD player or your DVD program would then be able to decrypt it and play said video or music or whatever's on the DVD. The problem is that, so first of all, if you were to pass a secret message to your friend, and you write it out on a piece of paper, encrypt it with the Caesar cipher or RSA or whatever you want, and I take it and photocopy it, I now have 2 copies of your encrypted message. And just the fact that it's encrypted doesn't prevent me from copying it. Then I can give either the original and the encrypted back to your friend. It's the same thing with DVDs. Yes, they are encrypted on it, but you know what? You can make an exact duplicate of the encrypted one. You now have 2, both which play in any DVD player because a DVD player can decode it. So it doesn't actually matter that it's encrypted. It can still be copied. The MPAA, the Motion Picture Association, kind of ignored this minor hitch in their encryption scheme. Somehow figured that even though it's encrypted, they still can't make photocopies of it. Whatever. And turns out that someone figured out how to crack that particular encryption. It actually wasn't all that hard. Well, I mean, it ended up not being the greatest encryption scheme. And John Jonasson, he was, I think, 13 or 14 in Norway or one of the Scandinavian countries, actually cracked it. So I was talking to somebody involved in this a week or 2 ago, and he's partly sort of a front for a group of people, but anyway, he did this and posted this on the internet, which then said basically anybody could then decrypt the image on a DVD. The reason this is useful is that I can copy an encrypted DVD and play the copy in any DVD player. But if I want to play it on Linux or Windows, and I want to actually write a DVD playing program, I need to be able to decrypt it in order to view the video. And that's why people wanted the keys, not so they could copy the stuff, because no one cares about the key to copy it. You just stamp out another copy of the encrypted thing. It's just so that you could create a player on a computer. The software needs to decrypt it to play it. So the MPAA was really pissed about this. I'm actually getting somewhere with this rant, believe me. The MPAA was kind of pissed at this, and they said, that's illegal. Well, it turns out that you can make an implementation of a code illegal. Like an actual program can be illegal, but you can't make an algorithm illegal. And what they tried to do is they tried to say that the way that this was gone and created, the algorithm or the formula for doing this was illegal, which was the first time that anybody ever had tried to make an algorithm illegal. So this is that illegal algorithm. Yeah. And this doesn't mean much to me. It was sort of crammed into, really small text, so I could fit it on there. And what happened is that a lot of people kind of got annoyed that the MPAA was trying to make an entire algorithm illegal. Not just a program, but an entire algorithm. Like anybody who wrote this, even outside the US and other countries that have very different laws, should go to jail. And a lot of people are kind of unhappy. So they created a competition for how to set up this particular algorithm in such a way that it sort of goes to the borderline of what's free speech and what's illegal algorithm. For example, this shirt happens to have that algorithm, as does the tie. So if the algorithm is illegal, therefore the shirt and the tie are illegal. That's CSS descramble, that's sort of a somewhat expanded version of the code. Somebody took it and read it in a haiku. And here we have blah, blah, blah. All these numbers, there's a lot of constants or variables, and you're just reading through 51, then 1, 115, 59, and basically spend all the time doing this as a haiku. Is that the illegal algorithm, or is it artistic expression? So someone took this haiku and then put it to accompaniment. Someone did a square dance version. You can actually get this read as a square dance or as with guitar and drum accompaniment. This prime number happens to be that algorithm. So any computer program, you convert it to binary, poof, you have a number. This is possibly the world's first illegal number. And the thing is big prime numbers are actually very useful in certain applications. Most realistic encryption schemes actually use really big prime numbers. So this is an illegal prime number. This image has that algorithm hidden inside it. And what happens is if you go to a page and you view this image, that image gets stored on your computer in cache. Basically, so it doesn't have to load it every time you view to that page, it stores it on the computer. Well, the particular way the law works is that if you have this algorithm on your computer, it's illegal. But then if you go to a website that views, I mean, it's hidden in there somewhere, and only if you know exactly what to look for can you find it. Does that mean that anybody, excuse me, anybody who even views that web page is then going to go to jail? That also is a way to decrypt it from the image. And so a lot of these, I mean, the purpose of the contest was to sort of show that you can try to make it illegal, but there's a lot of ingenuity out there and people who don't really like the MPA's heavy-handed techniques for doing this. So this is the particular website where I got all this information. And this is David Turetsky, who's a professor at CMU. And I met him at a conference I was at, and I shook his hand, I thanked him. Anyway, he was pretty happy because I'd read through his website quite a lot. Anyway, you could view recordings or movies, and it turns out that they also did an entire movie of it. You know the Star Wars scroll that goes past in the beginning of the movie? Well, they did that with the entire code.
Does it go with the dance?
Does it go with the dance? I suppose you could dance to it. So it turns out that the movie is actually, the link isn't there. So I'm going to do a little accompaniment. Oh, this is going to be loud. Princess Leia gets shot in her ship, etc., etc., and the rest of the movie keeps going. So it's actually just an entire scroll, all of the particular code. And again, is that free speech, or is that illegal algorithm? And I'll be honest, I have no. I think people should get the money for what they deserve, but I'm just not too happy with the MPA's heavy-handed techniques in doing this. So this is the whole story of DECSS and a slight tangent in the process. If you're interested, they have something like 100 different means of this, and or different ways that people have made haikus, poems, that sort of stuff. The MPA finally gave up on it because, again, it doesn't prevent you from copying because you can take an encrypted DVD, have no idea how to unencrypt it, and still copy it. The MPA finally gave up on it, and at least they haven't come and arrested me for putting this on my slide set. So that was my Star Wars reference for the day. I have actually another 1 or 2 Star Wars references coming up this semester.
So can we get an email with this code on it?
Can you get an email with it? Well, that's the thing, though. If I email you that picture, then you have it on your computer. Is that illegal? No, I'm not going to email you the picture. And if you want, I can delete. Well, I'll probably delete these slides or have alternate version of the slides so that you can be safe and they won't come after you. So, all right. Let's talk a bit about, that was actually, I think this was my longest red slide break this semester. So consider this code. Circle C1 equals new circle. That, of course, creates a circle of radius 1, right? Because that's the code that we provided. That creates a circle of radius 2. And we have two circle constructors. We define two. Here we're using both. Java knows which one to call based on the parameters you pass in. If there are no parameters passed in, it calls the constructor with no parameters. If there's one double parameter passed in, it calls the constructor with a single double parameter, with one double parameter. So this, as I mentioned, is called overloading. The circle keyword, in terms meaning the circle constructor, has multiple meanings. We saw this with string.substring. It can take in one or two integer parameters. And it means multiple things depending on the context. So you've seen overloading before. The plus operator, it can add integers, it can add floating point numbers. It turns out those are done differently inside a computer. It can stick strings together. It can do a lot of different things. So let's look at these set of circle constructors. I'm assuming pi is not final for some reason. Yes?
On the last slide, you put circle C2 with new circle 2.0.
Uh-huh.
Why did you just put 1.0 and just didn't have to do whole 5.0?
Well, this is slightly, so I could have certainly done circle 1.0. I just picked some random value. So this, I just picked some random value to show that it's using a different constructor.
So, like, for this particular example, it's not as necessary, like...
Yeah, I'm ignoring the whole private public thing for this example. Here I'm just talking really about overloading. So yeah, I mean, I just picked some random value so that it would use the other constructor. So let's say I still have my original default constructor. I have this as my specific constructor, which is the one that we've seen so far, and I also have this as a specific constructor. I'm assuming pi is not final for this. So the one version of my specific constructor can take in a value and set the radius equal to it, and the other version can take in a value and set pi equal to it, if we wanted to change the value of pi for some reason. But now when we call circle 1.0, which one does it call? And notice that Java can't tell which one to call. Because it says, okay, you passed in a double. I'm going to call the constructor that has a double. And it sees that there are two of them. And Java has no idea which one that you mean. So you can have as many, for any given method name, whether it be constructor, the circle constructor, substring, value of. You can have as many different versions of the method as you want, as long as each one has a different parameter list. When I say different parameter list, different types. Here, yes, one's parameters are, one's called p, but as far as Java is concerned, they're both double. It sees circle 1.0, it has no idea which one you want. So as long as it has a unique parameter list, meaning its parameters or the order of its parameters is different than any other one, Java will be happy. Java would not like this one because it has two methods have the same parameter list. So, as I mentioned, it turns out there's one more way that we can set the radius equal to 0, which of course is a bad thing. So this is our specific constructor that we talked about. And I can then call this code. And I say circle C equals new circle 0.0. And that passes 0 into the constructor. Constructor dutifully sets the radius equal to 0, and we're kind of back where we started. Right? We call it 1 over radius. That crashes just as before. So this ends up also being fairly easy to solve. So again, this is dividing by 0. And the reason is that the constructor directly set the field of that particular object. So I'm going to do it this way. I'm going to change my constructors that instead of directly setting the fields, going back slide, there we go. This directly sets the field, and the default constructor from the previous slide directly set the field. I'm going to instead call the mutator. Set radius 1.0, set radius r. So what this specific constructor does, it takes in double r, whatever r is, and it passes that into the set radius method. It's the job of the set radius method to make sure that the radius is set appropriately, meaning not 0 or negative. It's not the job of the constructor. The constructor just takes in the value, a new value for a radius, and passes it to the set radius method. It's the set radius method job to set it appropriately. This code as is can never, ever, ever have the radius set equal to 0 or a negative number, along with obviously the previous code we've seen. Even if you pass 0 into the specific constructor, it passes 0 into the set radius, and the set radius is not going to change it to 0. So this is certainly one reason that we like mutators. It controls how the field is changed and will not update it to a bad value, whatever bad means. So here's another reason we like mutators. Let's assume that we now have a circle class that has other properties. Diameter, I'm not quite sure why we would want diameter that's separate from radius, but let's assume that we do. And size. Size is string. It can be like tiny, small, medium, large, huge, gigantic, that sort of thing. So our mutator is now going to be this. This sets the radius. Checks to make sure the radius is this checks to make sure the radius is a good value. I have the if condition slightly reversed, but it does the same thing. If the radius is a bad value, set it equal to 1, else set it equal to what was passed in. Set the diameter equal to twice the radius, and depending on the radius size, 1, 5, or 10, or more, I'm going to set the string equal to small, medium, large, or huge. I just had to come up with something. I mean, the point here is that now my mutator method is 10 lines. And if I was to directly modify the radius outside the mutator method, like if my constructor just directly set the radius, I would then have to also modify the diameter. So first I'd have to check the radius was a good value, then modify it, update the diameter, update the string size. And that's it starts becoming a bit of a pain to copy that code everywhere. Because now my mutator is a lot more complicated than just checking the radius and then setting it if it's a good value. So by calling the set radius mutator, I will always ensure that all the other fields, such as the diameter, are updated appropriately. So this is another reason we like this. We don't have to copy this, 12 lines of code elsewhere in our Java program. It's in the set radius method. The set radius is in charge of setting those fields appropriately. And if we modify the radius directly, we would otherwise have to start worrying about that. So if we modify the radius field directly in one of the constructors, we would then have to worry about all this stuff, and we don't want to really have to deal with that. So this is another reason that we like mutators. Right. I think I'm going to stop there because that gets into static methods. Have a great weekend. I will see you all on Monday.